Welcome to myprojectbazaar.com. Our product title is Power Quality Improvement of Permanent Magnet Synchronous Generator Based TG Set Feeding 3-Base Loads. Let us see about abstract of our product. Realization of future microgrids requires that all technical issues such as power and energy balance, power quality and productions are solved. One of the most crucial one is the production of microgrid during normal and island operation. In this proposed implementation is focused on power quality improvement of a permanent magnet synchronous generator based diesel generator set feeding 3-base loads using a static compensator, a 3-leg voltage source converter with a capacitor on the DC link is used as a STATCOM. A pulse width modulation current controller is used for generation of gating pulses of metal oxide field effect transistor of the 3-leg voltage source converter of the STATCOM. The STATCOM is able to provide voltage control, harmonics elimination, power factor improvement, load balancing and load compensation. The performance of the system is experimentally tested on various types of loads under steady state and dynamic condition, while the grid side 3-phase inverter regulates the net DC bus voltage and reactive power to the grid. A significant improvement in the grid power quality is accomplished as the 3-base inverter no longer controls the DC link neutral point voltage. This proposed work is implemented in MATLAB simulating environment. Next we see about flow diagram of our product. In this flow diagram having several blocks such as permanent magnet synchronous generator, diesel engine set, passive elements, 3-base linear and non-linear loads, voltage source converter and controller. Generally the permanent magnet synchronous generator is nothing but it is a generator, whereas the excitation field is provided by a permanent magnet instead of a coil. The term synchronous refers here to the fact that the rotor and magnetic field rotate with the same speed. Because the magnetic field is generated through a soft mounted permanent magnet mechanism and current is induced into the stationary armature, synchronous generator are the majority source of commercial electrical energy. Next one, diesel engine set is coupled with permanent magnet synchronous generator. In order to stabilize the magnitude and the voltage frequency, the speed of the diesel engine is controlled. There must be a standby power source to meet the load energy demand. After that, that is connected with the STATCOM. The STATCOM is nothing but that regulates at its terminal by controlling the amount of reactive power injected into or absorbed from the power system. When the system voltage is low, the STATCOM generates reactive power. When system voltage is high, it absorbs the reactive power from the source. The variations of reactive power is performed by means of a voltage source converter. After that, using of controller is generating the pulses to the voltage source converter in the STATCOM. Then the load is a linear and non-linear loads are used in this proposed implementation. For linear load impedance remains fixed with change in applied voltage, whereas for non-linear load impedance varies with change in applied voltage. The change in impedance means that current will not change proportionally with change in applied voltage. A switching regulator is one of the example of non-linear load. A switching regulator takes lesser current as applied voltage increases. If the current through a load varies proportionally to the voltage across it and follows the voltage, the load is linear. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. The version is 2013A. First open the MATLAB window and create the new model file. After creating the model file, we arranging the elements as per the circuit diagram. After the arranging that elements from the circuit diagram, then click the run symbol icon. This is the run symbol icon. After clicking that, the corresponding output will be shown in the corresponding scopes in the circuits. First one, the source voltage of the corresponding circuit, and this is the source voltage and source current. And the next one, the control pulses is given to the voltage source converter in the overall circuit, that is a STATCOM voltage source converter. And next one is the output of the voltage source converter voltage, and this is the current waveform is getting from the voltage source converter, and this is the each space of voltage source converter current waveform. And this is load side voltage waveform, and this is load side voltage and current waveforms. And this is stator current IA and electromotive force EA waveforms. And next one is the electromagnetic torque in the unit of Nm. And next one, the rotor speed in the unit of RPM. And next one, the TST measurement. Overall process is efficient is measured by this kind of measurement. This is a TST measurement. In this source voltage, the TST value is 13.93. Then load voltage waveform is shown in here. The TST value is 0.93%, and also it is the load side voltage, this is also 0.93%. So overall TST value is less than 1%, so the efficiency will be increased. Thank you for watching this video.